To access the spectrum analyzer, press the front panel test key, then use the front panel cursor arrows to highlight spectrum analyzer, then press the front panel select key. We will be explaining the control functions you see highlighted in red. These items will be controlled by using the soft keys on the right. We will start with the vertical soft keys. The up-down arrow keys adjust the reference level. This gives the user the ability to vertically adjust the RF signal on the display regardless of the signal power. The expand, contract soft keys control the scaling dB per division drop-down menu. You can set the scale to 10, 5, 2, or 1 dB per division. From the vertical selections, you can also turn the preamp on and off. When the preamp is on, the noise floor levels around -140 dBm can be achieved. We can press our return key and get back to the main soft key menu. Next, we'll press the horizontal key. The expand, contract soft keys adjust the span of the trace. The span settings indicate the span of the full display. For example, if the span is 10 kHz, the vertical graticules of the display represent 1 kHz per division. The left-right arrow keys move the trace left or right one major division, which simultaneously adjusts the center frequency. Next, pressing the Find Soft key sweeps the test set's available frequency range and sets the center frequency to the highest signal peak along the frequency range. Pressing the full span sets the start-stop signal span to the test set's frequency range. Then by pressing the Find Soft key, it will bring the highest signal to the center of the display. We will now press the Return key. The next item is the Coupling Soft key. The user can set the resolution bandwidth, video bandwidth, and sweep time to auto or manual. With these functions set to manual, the user can adjust the resolution bandwidth, video bandwidth, and sweep independently. Be aware that the spectrum analyzer will display an uncal condition if these items are set in such a way that misrepresents the displayed spectrum. Resolution bandwidth, video bandwidth, and sweep time settings are all interdependent. When they are set to auto, the test set optimizes these settings. The next item is the Marker Soft key. The Marker 1 and Marker 2 soft keys enable or disable a corresponding marker. The lock state links Marker 1 and Marker 2 together at the current frequency spacing. When the markers are locked, moving Marker 1 or Marker 2 moves the other marker while maintaining the current frequency spacing. The Marker to Start-Stop soft key sets the left edge of the trace to Marker 1 and the right edge of the trace to Marker 2. Marker 1 or 2 to Peak soft key moves Marker 1 or 2 to the position of the peak value shown on the current trace. Marker 1 or 2 set CF soft key sets the center frequency to the reading of Marker 1 or Marker 2. The user can also move the markers to any location on the screen with the left click of a USB mouse. You can also access all of the analyzer markers at one time by pressing the Config key. When it reaches its function window, press the Config key again and select Analyzer Markers from the menu. You can set 6 vertical markers and 2 horizontal markers from this screen. By pressing the Return key, you will return to the Spectrum Analyzer. Marker 1 through 6 are displayed in frequency and level. Marker 1 and 2 display a delta function in frequency and level. Markers 7 and 8 are set in the Analyzer's Markers tile. The next item we will discuss is the Trace soft key. When the Capture soft key is pressed, a trace is held on the display as a static green trace. Captured traces can be stored and recalled using the Store Recall soft key. When the Average soft key is on, the trace is calculated by averaging the number of measurements defined in the Average field and displayed in yellow. When the Peak Hold function is on, the maximum value of each frequency point is displayed to produce the red maximum trace. When the Set Reference key is pressed, the test set stores the current trace data, which is used to establish a reference trace when the reference mode is selected. When the reference mode is selected, the test set uses the last stored trace reference to establish a frequency response of the characteristics of the cabling or test setup. This response is used as a reference for the active trace being displayed on the Spectrum Analyzer tile. We are now going to use some of the items that we talked about in this video to locate an interfering signal inside our channel bandwidth. We will start by reducing the overall noise level by turning the preamp on. Because we have two signals closely separated in frequency, we will reduce our resolution bandwidth to 300 Hz. We will also lower our reference level to neg 100 dBm and reduce our vertical scale to 5 dB per division to enlarge our display. To further reduce the noise, we can press the trace soft key and then toggle the average soft key to on. At this time, we can bring a couple of markers up to the display to give us further information about our signals. Because we have the resolution bandwidth filter set to 300 Hz, our markers are not showing true power of our signal. If we have the occupied bandwidth option, we can turn it on and it will display true power and the occupied bandwidth of our spectrum. We can also monitor our spectrum over time. We can turn the peak hold function on and the average mode if desired. Keep your eye on marker 2 as it is monitoring our interfering signal. Markers are displaying the peak indication of the signal, so if the signal is only up momentarily, we will still have a relative level that the signal achieved. In standard configuration, the spectrum analyzer frequency range is usable from 100 kHz extending to 1.05 GHz. With option 58 installed, the frequency range is extended to 2.7 GHz. The displayed average noise level is negative 125 dBm, typical with 300 Hz resolution bandwidth, antenna port terminated, and a 20 dB sweep average. When the preamp is turned on, the 3920 has a typical noise figure of negative 9 dB, leading to a spectrum analyzer noise floor of approximately negative 140 dBm with a 300 Hz resolution bandwidth filter selected. This ends the brief overview of the 3920 spectrum analyzer.